All right, so here we have a population that's actually decaying, much like carbon-14 could. So they say decreasing. That's the key thing that also means decay. All right, but the population 5 years ago was 1,900. Today, only 1,100 of the fish are alive. Once the population drops below 100, the situation will be irreversible. When will this happen according to the model? All right, so let's start out with what we do know. All right, first thing we need to do is find this K value, because we're unfortunately not given that. If you're ever not explicitly given that the rate of population increase or decrease is something, you need to go find it. So what we do know is that 5 years ago it was 1,900 and today there's 1,100. So the current amount is 1,100, and it was originally, this is always the original amount here, was 1,900 e to the k, and that was 5 years ago. All right, so we divide both sides first by 1,900. Let's get that put together. So on this side we have 11 over 19 equals e to the 5k. All right, now we'll take the natural log of both sides here. And when we do that, that allows us to bring this 5k down. So we have natural log of 11/19 equals 5k ln of e, and ln of e is defined as 1. It's a definition that it's equal to 1. So we divide both sides by 5. And doing that, we get k. And so entering that in my calculator, I get that k is negative 0.109308, so on and so forth. All right, so that's k. So that right there is k. So now we can write a equals a0 e to the negative 0.1093. That should probably be enough decimals there. T. All right. So now the question is, once the population drops below 1,100, the situation will be irreversible. All right, so now we're actually going to shift and say now, because today the amount is 1,100, that's going to be now the original amount. You could use 1,900 here for A0 if you'd like to continue with what we used over here. Just know that the number of years, T, that we're going to find will be the number of years from when it was 1,900, so you'd have to add 5 or subtract 5 from our result to get the number of years from today. So again, all these answers down here say from today, and so today is what we're going to look at as 1,100, and in the future, when it gets to 100, we're in trouble. All right, so again, just a word of comment there. Why we use A0 is 1,900 over here, and over here is 1,100. It's because the ultimate question of T is about when it will be from today, which is 1,100. So we divide by 1,100 on both sides. So we get 1 over 11 on that side. And then over here, and now we're going to take the natural log of both sides. And again, do the same trick we've been doing for these problems. Natural log of 1/11 is negative 0.1093t ln e, and ln of e is 1. And so we divide by negative 0.1093 on both sides. And that will give us our answer. And so doing that math, I get 21.938. And so we would call that 22. It rounds up to 22 years. So 22 years from today would be answer A. And again, here the rounding is not as critical with a 0.1093 because you'll probably get 21.9 or 21.8. You end up rounding to the right whole number year. So this one's not quite as sensitive in that regard. But again, also, if you, you could even do this just to check for fun. You can change this 1,100 to 1,900, and you should get, if you did all that math again, you should get 27, or 26.9, but you should get 27 years from the time when it was 1,900, which is kind of neat that you could use either point, and you would still get to the same result.